developed using plant material. You know, probably you do know that people use the plant material. Now, very recently means like few years back, they actually use some of the carbon nanotube antenna and put it on the plant's leaves. So now, when the plant leaf actually takes that energy from the sunlight, it has a limit. It takes like 10% or something. So when they put this nano antenna, so now through this nano antenna, a plant can take more than 30% of the solar energy into it. So this kind of the technology can be used as a solar panel, because you're taking a lot of energy and putting inside it. So, but you said that human hair. I don't have the idea that why. But maybe, I mean, what is your I don't know. Maybe anything in science. What I can say in science and technology, anything is possible. Anything, right? Just we have to find a way. That's all.
Thank you, sir. We have another question from Jornotso Dashgupta. He says that if we are able to make a body part in space, how good will it be for the patients?
No. So the question is, what I'm telling, that doesn't mean that we have to make in the space. So what makes this body part? Because if you make the space, you have to bring it down. I mean, that people can do that. I mean, but what you need, the microgravity. So as I showed, that we have for example, we have a microgravity simulator in the lab. So there is a lot of other microgravity simulator. So we have a big microgravity simulator. So you put, instead of a simple reactor where you want to grow your cells, you put a microgravity simulating reactor, the whole thing. So the microgravity will help you to make this three-dimensional. You don't need to go to the space. You can do those kind of things on the Earth. But in terms of the semiconductor processing, no, because the dust is the problem, and you cannot make the semiconductor inside the water. So that case, you have to go to the space.
Is there anyone who wants to ask something else?
Hello.
See any more questions in the chat box?
Hello, am I audible?
Yes, sir, you're audible.
Sir, one thing you just want to say, that here are so many students are there. So how they can make their career in the field of synthetic biology? So please give an outline.
Oh, sure. So first thing also I'll tell that the synthetic biology actually developed by the engineers only. Okay. So for example, my PhD supervisor, who was a space engineer, he did his PhD on the space engineer, and his algorithm for making the robotic communication has been used on one of the rover Mars mission. So now when he was listening to a talk to synthetic biologists who actually developed the fast toggle switch and the memory switch, so my supervisor realized that what about the algorithm he used in this communication of the robotic device, the same kind of the algorithm those guys are using in the connection of the genes. So he interested in synthetic biology, went to synthetic biology, and when he came as an assistant professor at University of Toronto, I joined with him. So basically, my background is also in the after BSc, I also did a BTech on chemical technologies, petrochemical engineering. So that is also so a lot of people actually in the synthetic biology came from this engineering. So I think the one way to go, I mean, one way, there's something called the iGEM. So if you just search in the Google, and it's called the iGEM, International Genetic Engineering Machine Competitions. So there is a lot of engineering college from the India is actually take participation on that. So if you are interested, you can actually go, and that competition give you a lot of different learning resources, a lot of other resources. So this is one way to do that. Second way, so the synthetic biology is, if you want to go, there's two ways to go. One is if you want to do some higher studies on it. So you can think about doing PhD on synthetic biology. And nowadays, I think US doesn't need any GRE, right? So last couple of years they are not asking for the GREs. So if you have some synthetic, so first thing I will study a little bit on the Google search. If you can do the iGEM, that is good. If you can take some your summer, okay, instead of a company, when you do your industrial research, I mean, if you take some lab where people are doing synthetic biology research, you have a certain kind of experience and then go out at very good. So I know like a couple of students definitely did from Sipur. They're specifically electronics, at least 2 electronics engineers actually worked with me during the summer project. So that is one, and then you can do your PhD. And another thing, there's a lot of synthetic biology company, they ask for because there is a lot of the data, they do need someone from the computer science or electrical or electronics who can actually analyze those data in various ways in the data science or something. So another aspect, if you can go such kind of a company, if you look at, because I know that you don't look the companies other than your hardcore or IT system, but these are the companies they always look for those kinds. So you can think about connect those with those companies. So iGEM is a very good resources. You go and you learn many things, so which are the companies, what they're doing there, and where to connect, how to do that. So this is a very useful resource, I believe.
So thank you. We have Pompo Kundu asking where India stands in the field of synthetic biology.
Okay, so everything India starts for a long time. So there's a so at this moment there are so okay, let's say how this synthetic biology evolved. So what I presented here, that the synthetic biology started in that way. There is another part of the synthetic biology which is called synthetic metabolic engineering. Basically, you are producing a lot of chemicals inside the organism, bacteria, yeast, or so on, and these chemicals can be useful for many industrial processes. So in India, whatever the synthetic biology community is, there 90% of the community or 95% of the community are making those kind of the chemicals on those things. So those are in my opinion, they are not real synthetic biologists, because those are again is a genetic engineering. You are doing industrial microbiology. So from a electrical or computer science perspective, what the circuit things are the basically they're electrical. I mean synthetic biology, and there is only few groups are doing. Definitely my group, and there is a Sonak Shen, and he's in IIT Delhi. So he is trying to. I mean, he has an experience in both modeling and experiment, but he's just doing the modeling. He hasn't started the experimental things. And there's Amit Ghosh in Kharagpur IIT in Energy Science Division. He's doing trying to something like that. And there's a Professor Pabondhar in JNU. So there's a community is very very less, but what I can say, the opportunity is enormous.
Thank you, sir, very much. We have Adrish Day asking, which is better, biotechnology or bioengineering?
I mean, first thing is that what do you mean by bioengineering, biotechnology, and better in what sense? So what I showed here is basically that how our future evolves. So I mean, you can say the synthetic biology is a part of the biotechnology or bioengineering, right? Because but the whole goal of the synthetic biology, you want to come with a design-based perspective. But in biotechnology, it's not a design-based. There's like mostly it is like a trial and error. But in trial and error, you cannot do many things, right? That's I showed like those kind of switch, those kind of artificial neural network, those kind of classifier for the cancer, okay, or biohybrid robotics. Those you cannot do with the conventional biotechnology. What you do need, those kind of the principles, design-based principle, and that's the synthetic biology. So I mean, there is nothing like to say that what is good or better in what sense. I mean, they're all same. It is question is what interests you the most. If it interests to making the chemicals, you can definitely go to the biotechnology. If it interests to do this kind of research, what I just showed you, then definitely the synthetic biology is the key.
Thank you, sir. Dharnotra is again asking that if you can go there if you have a mechanical background.
Yeah, exactly. Because there is a many people come from the civil, many people come from the mechanical. Because many of my when I was doing my postdoc and a couple of students who are doing the PhD in our lab at chemical engineering department, and they are basically the mechanical engineers. There's undergraduates from mechanical engineering. So one thing I'd like to tell you for all the students, that science or engineering or the technology, here we divided like electrical, light chemistry, like things. But when it comes to solve a problem, you cannot pretend you are something like that. So if I need to know the mathematics, I have to know the mathematics. If I want to learn the biology, we have the biology. So we, specifically in India, people are, we are responsible, like, right? So what makes that we said, oh, you are electrical engineering, you're just electrical engineering, you are a physicist, you're just a physicist. It's not like that. It's never been some kind of thing. You start with one undergraduate degree and you can do anything you want. It doesn't matter if you're starting from the linguistics and you come to the physics, right? We know that's those kind of things are like de Broglie was a linguist, not the linguistics. De Broglie was like a music students basically, and he got the Nobel Prize in physics. So there's no bar. You can come from it. Is only depends on what you really want to do. If you really want to do from the heart, do that, right? It is not like how much your salary. I mean, if you think of the engineering, today's in Indian engineering system, I must say that we lost the charm of the engineering, because we want to think in terms of that what we can do in terms of the salary, what is the product and something. But engineering is not about the product. It's not about the economy. Engineering is something that something does not exist in the nature, and we want to make that. So that's the creativity, right? That's creativity is the engineering. So that is, if you have the passion of the engineering, you can do that. Then Elon Musk has something to do which is only the passionate person can do, right? You cannot just do like it. So it is all up to you. I believe that if you want to do something, you want to be a singer, you want to be a synthetic biologist, you want to be a physicist, you want to be electrical engineer, it's just up to you. Okay, so you can do anything. Sorry, I cannot hear anyone.
I've gone mute. Sorry. Yeah. Thank you, sir, very much. Thank you for your valuable speech. Thank you for your valuable time. And I would now like to request the head of the Department of Basic Science and Humanities Department, Dr. Rajdeep Chakraborty, for delivering the vote of thanks. Sir, over to you.
Am I audible?
Yes.
Oh, thank you. A big thank you to you. Thank you for the wonderful session. Respected principal, dean academics, most valued invited guests, and my dear students. It's my privilege to propose a vote of thanks on this occasion. On behalf of the Departmental of Basic Science and Humanities, RERF, I extend a very hearty vote of thanks to the speaker, Dr. Sangram Bag, for gracing your important work and sharing with us your findings and opinions today. Again, a big thank you to you, Dr. Bag, for your effort towards today's presentation, and particularly the issues you have raised for a new emerging technology. So we are all inspired by your words. Again, I'm really happy to see the number of my beloved students who have participated in the program, and hope that the students can explore your thoughts in the future in the field of synthetic biology, which is shown by Dr. Bag. Again, I would like to extend the hearty thanks to my colleague, Mr. Ovi Ghosh Dostidar and Moinak Sarkar, for the perfect logistic support and technical guidance that they have extended to us to make this program successful. I also extend my thanks to our principal, Dr. Muhammad Das, and Dean Academics, Dr. A.K. Shaw, for their support in various academic issues. But last but not the least, I am very fortunate to have a team of very motivated and dedicated colleagues in my department, without whom no events can become successful. Thank you. Thank you all.
And it's my pleasure to be here, and I thank you all of for listening and inviting. And really, I enjoyed. Thank you very much for this session.